any joins in the wide column database. There is no support, and the data modeling can sometimes become a bit hard. Okay, so this was the wide column database in NoSQL. Now let's see how we will deal with the same data in the fourth category of NoSQL, which is graph database. Alright, one of the famous graph database is Neo4j. Okay, now let's see how we will store this data. Okay, so this is how the data is stored. User is the node, orders is the node. Okay, as both node and edges can have the properties. So here user has this property 101, and here corresponding to order we have this 1 and the amount 500. Okay, similarly in second one user is 101 only, order is 2 and 300. These are the properties. So these are the nodes, and the edge or the relationship is placed. So user placed order. Okay, so this data is stored in this way in graph database. Now how can you read this data? So you can read in this way. Match, you provide the node and then provide the ID, and this is the relationship. Okay, and corresponding to it we get this output. So basically we are trying to find the match for user ID 101, and this is the edge or the relationship, and corresponding to it, it will return you both of the orders because user 1 placed 2 orders. So both of these things match for these 2 orders. Now let's see the pros and cons of graph database. So graph database is good in relationship queries because graph database is based on relationships. Okay, so the relationship queries are good. So if the relationships are deep or complex, then you can use the graph database, because if you use the SQL database, there will be a lot of join operations there. And hence the graph database is really good when we talk about social network apps, okay, where you have to find the connections of the connections, so friends of friends kind of thing. So these are the good thing. When we talk about the bad, although graph database is type of a NoSQL database, but it struggles in terms of horizontal scaling, similar to what we have in SQL. Okay, apart from that, graph database is good for complex or deep relationships, but it is not great if you have to do simple CRUD operations. Okay, and it is slower for bulk writes as well. Now that we have discussed about SQL and all the 4 categories of NoSQL database, I have a brilliant question, and I think you also might have the same question in your mind, which is what is the difference between SQL versus key value database versus document database versus wide column database versus graph database. So these are 4 categories of NoSQL database, and this is SQL database. So what is the difference? So let's try to understand this. Okay, first of all, if we talk like how all of these database store data, so talking about the structure, in SQL we follow the tables, like you have the Excel, right? You have the rows and columns. In similar way, SQL we have the tables. When we talk about key value database, we store it in the structure of key and value. So you have the key, and corresponding to that you store the value, right? Then we have the document database. It stores a unit as document, and the format is generally JSON. Okay, when we talk about wide column database, we have the rows. Generally we keep the row key, and corresponding to that you have dynamic many columns. It can go even in millions of columns. Okay, next we have the graph database. In this you have the nodes, edges, and the properties. So this is how all of these store the data, and you can clearly see there is difference how they store the data. Next, if we talk about the schema, as SQL is relational database, it is known for the strict schema. Okay, when we talk about key value database, there is no schema. When we talk about document database, so it has flexible kind of schema. Talking about wide column database, it has semi flexible schema because you have the column families and columns. Okay, so it's kind of semi flexible because different row keys can have different amount of columns, but of course you have the columns, like you define the family, right? Whereas when we talk about document database, you just have the data in the document. So in document you can keep any format or any schema. So in that way document database is more flexible. Okay, talking about the graph database, we have the nodes and edges, so it is also quite flexible. Next, when we talk about the joins, SQL is known for the joins, right? Because relational database is like you have multiple tables and those tables are connected or have relations using the keys, like the foreign key, right? And because you have different tables, when you read the data, so you would require the joins. So SQL is strong in joins because it's kind of the core feature of this database. When we talk about key value database, there is no support of joins here, okay? Because it's a NoSQL database, it's not known for the joins. Talking about the document database, it provides a support for the joins, but overall it is quite weak or limited support for joins. When we talk about wide column database, there is again no support for joins. And in graph database, there is support for joins, so you can say good in joins, but of course SQL is best when we talk about the joins. Okay, next, talking about the scale. Okay, in SQL it is quite hard to do the horizontal scaling, or you can say the sharding part. We discussed in detail about that earlier in this video, because SQL is known like it was like built before all these distributed problems. It is quite old. It was built in a way like you will have one kind of database and you will keep on increasing. It's more about the vertical scaling. But when we talk about the horizontal scaling, which would be required if you have a huge amount of data, because you cannot have all the data in complete kind of system, right? So when you have different shards, right? So of course there are many problems. Joins also become distributed. There are a lot of issues in that, right? There will be network calls, it will become slow, and it is difficult to maintain the ACID support, strong ACID, which is the key feature of SQL when we have different shards, right? So what we do in that case is like we handle the sharding logic in SQL at application level. We try to keep all the data which is related in one shard so that we don't have to make like distributed joins and the problems that we discussed, right? So that is handled at the app level, and hence it is quite hard when we talk about horizontal scaling in SQL. Now, the NoSQL databases are generally built in a way that horizontal scaling is not that big of the issue. So when we talk about key value database, it's very easy. The horizontal scaling, it's kind of built-in kind of automatic feature. Talking about document database, again, it's easy. In wide column, it's very easy. Just you can say an exceptional case, graph database, it is hard to have like the horizontal scaling, because if you have like different partitions, it has to check the relations. If it is in the different partitions, it will become difficult. So the horizontal scaling is bit difficult when we talk about the graph database as well. Next, talking about the transactions, as we just said, SQL provides strong support for ACID properties, atomicity, consistency, isolation, durability. Key value database, it doesn't provide ACID support. Okay, talking about document database, it has limited kind of support for this ACID properties. Wide column database, again no support. For graph database, because it is based on the relationships and you can see bit of the similarity with SQL, although graph is a NoSQL database, but it provides good support for ACID properties. Okay, last, talking about the query power. In SQL we have very high, or we have very rich queries that you can write. We also have joins, right? We discussed about different types of joins actually in SQL. So in SQL you have very rich queries. You can query based on all the fields, properties, joins you can apply, right? When we talk about key value, the query power is very low. Why? Because you can simply query based on the key. You cannot even query inside the value. So it's very low capability of the queries or read operations. Talking about document, it is kind of medium, much better than key value, because you can even query on the field inside the document. So in that way, it's good as compared to key value, but of course not matching what we have in SQL. Okay. Next, wide column. Again, it's very low because you need to know the partition and the row key for the queries, and it works on that way. So yeah, very low in wide column. And when we talk about the graph, it is mostly about the relationship based, like we saw, like it just match this relation. So in that way, it provides some of the capability. One more point that would be related to the write operations or the right throughput. In that, the wide column database is amazing because it follows append only that we discussed earlier, and because it can have dynamic number of columns, it can even go in millions, right? So the write throughput is amazing in wide column database. Well, of course, you have like relation between the tables. It provides like table structure, different tables connected via foreign key, amazing in asset support, right? Strong consistency. So this is used in most of the, say, banking applications, or where you need financial related transactions, because you need strong consistency there. So you always choose in that case SQL. When we talk about key value database, it is known for the fast lookup. Okay. So for the support like cache or sessions maintaining that, you generally use key value. You might have used or heard about Redis cache, right? So it is very famous, and like it provides like very quick support, because you simply query based on the key and it provides you the value of that key. Okay, so fast lookups is for what key value database is known for. So if you have object like data, because it stores everything in the, you can say, in a document, say the JSON format. So in those kind of things, document database is good. Also in NoSQL database, if you need kind of good query support or read operations, so with flexible schema, document database is good for that. Talking about wide column database, it is used for storing time series data. It is good for that, and also it is really good for high write throughput, right? So a dynamic number of columns which can grow. So if your data keeps on growing, for that, like wide column database is really good. So known for the high write throughput and for time series storage. Next, the last category of NoSQL database is the graph database. It is known for like relationship based. So mostly if you talk about like social networks, like friends of friends, or connections to connections to connections, first level, second level, third level. So if you have deep relationships, graph database is used for that. So you can clearly see this is SQL, and these are the type of NoSQL database. Okay, so overall, as we already discussed, SQL has the good things like schema is fixed, good for joins, very rich queries, strong asset support, strong consistency, but it has its issues like the horizontal scaling is difficult. But in generic, NoSQL is good when we talk about the horizontal scaling, because both has like different features. NoSQL is not known for like joins, for strong asset support, no, because it is designed in that way. It is solving different kind of issues, whereas SQL is providing different kind of features, right? So in that way, you can clearly see both are different, and we also discussed about each of the database, how they are different. Yeah. So overall, SQL is like structured data, strict schema, tables, good for joins, rich queries, strong asset support, strong consistency. Whereas NoSQL is for flexible data and, most important, automatic horizontal scaling, which is handled at the DB level. So till now we have covered about SQL database and NoSQL database. In NoSQL database, we have also covered all the categories of NoSQL, like key value database, document database, wide column database, and graph database. Now SQL and NoSQL are basically the major databases which we use. But apart from that, we also have some other databases which are required for some specific operations. So let's discuss about some of those database. So the first one is search database. So a simple question that would come to your mind is, what is a search database? So search database is a separate category. It's not SQL, not even NoSQL, but they store the data. It is used to find or search the results from the large set of text or data. Some of the key usages of search database is Google search, or the product search that you do on Amazon, log search, and autocomplete suggestions. What the search database care about is text relevance, partial matches, and the ranking. Now a simple question comes to mind is like, why normal databases are bad for this kind of search? So basically SQL or NoSQL, they can do something like this. You can search with the where clause and put whatever field is there and then put the value, right? So if you want to search for iPhone in the database, both SQL and NoSQL can give you that kind of data. So something you can say like exact matching. So you can also do like a wildcard kind of matching in SQL NoSQL, but of course the time complexity of that would increase. But when we talk about the search operations, they don't just need this exact word. Apart from this, they would also need something like this, where the user has made some mistake while typing, or in a sentence that basically word is present. All these kind of things are required when a person is searching. Right now, when we talk about all of these things, these require tokenization, ranking, scoring, fuzzy matching, and the regular databases like SQL and NoSQL are not built for this. Now the basic question comes like how the search database is able to do all this. The answer for that is using inverted index. Now what is inverted index? Let's try to understand that. So basically when we talk about normal index, it would be something like for a specific row you have a value, okay? But when we talk about inverted index, for a particular word we will keep the list of documents. I know it might sound confusing, so let's try to understand this with an example. Let's say we have two documents, okay? In the document 1 we have this sentence, iPhone 14 Pro Max, and in document 2 we have this sentence, Samsung Galaxy phone. Now basically these will be the inverted index that we will form from both of these sentences, okay? So what we will do is like we will pick each of the word. First is iPhone, right? So we will put it is present in document 1, correct? Then 14, it is also present in document 1. Then Pro, it is present in document 1. Then Max also, I think we missed the entry here, but for Max also we will have like this is the word, and corresponding to this we have like doc1, okay? Same as other words. And after that, in the document 2 we have Samsung, so corresponding to Samsung we have kept document 2, then Galaxy document 2, then phone document 2. So you can clearly see for each of the word we have maintained like list of documents in which this word is present. So for now all of the words were unique, so those were present only in specific document. So of course we will keep the original thing like this sentence, of course we will keep that, but apart from that we will also maintain the inverted indexes and some of the metadata. Okay, next let's see some more things related to the search database. So let's first see what are the types of search queries which are supported by a search database. Of course, first of all, the full text search, it is allowed in the search database, but apart from that also we have many other things, because this is also present in the SQL and NoSQL databases, right? But apart from the full text search, what we also require is partial match, like something like this. You have IPH, and after that you can say it's a wild case search, okay? So partial search we should be able to match. Although this kind of thing we can also do in SQL, like in the rich queries, you can provide the wild star operator also, and there are many other things that you can use, but of course the complexity increases for that. Next type is the fuzzy search, like for example instead of iPhone you mistyped it IPHNE, okay? Even for this it should be able to show you the result, because you might have seen when you try to type something on Google and you mistype it, it gives you a suggestion, did you mean this word, right? So it is able to search iPhone from this keyword also. Next is the phrase search, okay? So from any phrase or sentence it should be able to fetch the word and provide you that search result. Next is the filters, okay? You can also apply kind of filters like price is smaller than 50,000, and another thing is the aggregations. So all of these types are supported as search queries in search database. So like we discussed SQL, NoSQL. In SQL we have like rich queries. So SQL would be more used if you have to search for exact things or range, right? But the search database will be used for text similarity, okay? It is also able to search for all of these things, which is an important criteria when you are doing searching. Alright, next let's see some of the popular search databases. The most famous one is the Elasticsearch. You might have heard about Elasticsearch, right? So this is very famous, popular, and it is used widely when we talk about search based databases. Few more are like OpenSearch, Solar, and MeiliSearch. Next, talking about the consistency model of the search database, they follow eventual consistency. So they don't provide like very strong consistency, it's eventual consistency. So the search databases are optimized for reads. So whenever you make a write, there will be index update and that will be searchable after delay. Okay, so you may not always get the most updated data. Okay, so it provides you eventual consistency, not the strong consistency. So as we discussed earlier, the search database, we use it for, you can say, when you have to perform the search operations, right? You have to do all these kind of operations. You have to use for like autocomplete, or you have to do like product search, or even for log analytics, search database can be used. But next, when not to use the search database, it cannot be used as like primary database. As primary database, you would use either SQL or NoSQL. So this database is specifically used for the search operations. Okay. So one thing that you need to remember is like when we design a complete system, okay, inside this, you may have multiple microservices where each of the microservice is performing different tasks. Okay, and there might be also a possibility that you might be using multiple databases. It's not a must kind of thing that you would have to use only one type of database. One type of database can be useful for one kind of service that you provide, whereas other database might be better choice for any other operation or service that you provide. Okay, so for example, we talked about what SQL and NoSQL are good for and not good for, right? So when we talk about basic authentication, and if you have to keep like user specific information which is structured, then you will prefer SQL. Okay, if you have to see in some of the services about the right scale or horizontal scaling, then in that you would use NoSQL. Okay, even though you might be already using SQL, okay, you can have one more database, like you're using SQL, you're also using NoSQL. But apart from that, say there is some feature or service that you provide which requires a lot of search operations. So for that, you will use the search database as well. But the search database will not be used as your primary database. It's kind of like for the secondary operation where you are providing something like search related service. Okay, for that you can use it. And next, when not to use is for transactions and when you need strong consistency, because we just saw we get like eventual consistency in the search database, so it cannot act as your primary database. It is specific for the search related services or operations that you provide in your product. So basically you can imagine, as a primary database you might be using SQL or NoSQL, and then this search database, if you're using, it can act as like the secondary database. So it will pick the data from your primary database. Many models are there, like you can say through the events or something else, it will be getting the data, but the search database is not your source of truth. Okay, it is just used to provide a very smooth experience related to search operations. So we discussed about the search database here, but I know you might still have confusions about it. So let's take an example, and through that, let's try to understand more about the search database. All right, so this is the example that we will see for the search database. Okay, so you can see in both we have like the documents as a JSON. You can take it as like we are using the document based NoSQL database here. Okay, so these are the two documents that we have. Inside that we have the information like doc ID, title we have, description we have, price we have, right? Now what all things we will store? Of course, first the original thing, the documents will be stored. But apart from that, when we talk about the search database, there are two more things that are stored. First is the inverted index that we will create now, and second is the metadata. So clearly you can see there are a lot of words which are present in the title and description of both of the documents. Okay, so it will create the inverted indexes from these. Now how does it form the inverted index? Let's see the process. So the step one would be tokenization. What we are going to do is like break the text into words. So you can see the complete sentence or text here. Similarly for this, similarly for this and this. What we will do is like break it into words. So we have Apple, we have iPhone, we have 14 Pro. So all of these are present here. And then in the description, we have best camera phone. So you can see best camera phone here. Basically from the text, we have found out the words. Similarly, for document 2, we will create the tokens. First, for the title, Samsung Galaxy S23. So you can clearly see these are present here. And then from the description, we have Android flagship phone. So you can clearly see that as well. Okay. So from document 2 tokens, we get all of these. So now as we have the tokens available, what we'll do now is create the inverted indexes. Here you can see we have built the inverted index from the tokens that we have got. Okay, first token was Apple and that is present in document 1 only. Then iPhone, document 1, 14, document 1, Pro, document 1, Best, document 1, camera, document 1. Phone is something which is present in both of the documents. You can see in document 1 as well and in document 2 as well, right? Next we have Samsung, which is present in document 2 only. Galaxy, document 2. S23, document 2. So for S23 also we will create something like this, S23 and 2. Okay, because that is only present in document 2. Then we have Android. So Android, document 2. I think we missed out here. Similarly for flagship, we will create like document 2. Okay. Then phone we have already covered here. Okay. Only the phone keyword is present in both of the documents, right? So this is how we create the inverted index and they really help to make the search fast. Alright, so apart from storing the documents and the inverted index, what we also store is the metadata, and metadata helps us in ranking and filtering. Okay, so for example, we have like title and description present in the document. So in the metadata, we can define what will be given more priority or more weightage. So like title will be given more priority as compared to description, you can say. All right, so the basic point here is we store three things. Of course, we store the original document which we have here. Second thing is the inverted index. You can clearly see how we build the inverted index, and then we will store these inverted index. And the third thing is the metadata, which will help us in ranking and filtering. Okay, so now what I'll do is I'll remove some of the information from here because we want to see how the search operation is performed. Okay, all right, so these are our original documents. These are the inverted index. Of course, few of the inverted index are missing here, like flagship is missing, S23 is missing, but it's okay. I mean, you got the main idea how we are building the inverted index, right? So I've kept the inverted index here, and then we have this as a search query. Okay, the user has searched iPhone phone, right? So now let's see how the search database will search for this query. Okay, the step one is tokenize query. Just like we tokenize the documents, in which we basically fetched out all the words which are present in the document, right? In similar way, now we will tokenize the query. So all the words which are present inside the query, we will tokenize, or we will fetch out the words from it. So the words that we get from this one is iPhone and phone, because there are only two words in this query. Then the next step, step 2, is lookup inverted index. We have already created the inverted index here. So now we also have the tokenized query, correct? So the keywords which are present in the query, so we will search them in the inverted index. So clearly we will search for iPhone and phone in this inverted indexes. What we will get is like iPhone is present in document 1 and phone is present in two documents, document 1 and document 2. So you can clearly see we get this result, right? Quite easy because we have already built the inverted index here. So we just had to look up for the words in the inverted indexes. Okay, after this, the step 3 is find matching documents. So if our query was something, we have to find intersection, like both of these words should be present, we need to just return those documents. Then the answer would have been document 1, because in document 1 we have both the keywords, we have iPhone as well and we also have phone in document 1. So if we had to find out the intersection of all the words in the query, then it would have returned the document 1. But in case we have applied OR operation or the union instead of the AND operation or the intersection, then we would have returned both the documents, document 1 and document 2. Why? Because iPhone is present in document 1 and phone is present in both the documents, document 1 and 2. Now we have like applied the or operation, like any of the keyword is present in the document, return that document, then the answer would be this. If we were talking about the AND operation or the intersection, then the answer would be this. Correct? All right, next, the step 4 is scoring the documents or the ranking. We earlier discussed that we store the original documents, the inverted indexes, and the metadata. So metadata helps you in the ranking, in providing score to the documents, correct? So here you can clearly see the iPhone was present in title. So this was present in the title of document 1. And when we talk about phone, that was present in the description of document 1. Now in metadata, we store this kind of things like what should be given more weightage. So like I said, in the metadata, we decided to give more weightage to the title. So document 1 will have high score because iPhone is present in the title and phone is also present in the description, although description is given low weightage, but both of the keywords are present first of all, but very high weightage because iPhone is present in the title. Okay. And when we talk about the document 2, it only contains the keyword phone, right? And that too in the description. So document 1 will get higher score or ranking. Why? Because one of the keywords was present in the title, and in the metadata we defined title will be given more weightage than the description. Okay. So this step happened after step 3, where we found the matching documents, and based on what we got, we performed scoring of documents on that only, because here we are taking example of union. So we had both the documents, so that's why we did this step where we are scoring the documents, because we have to rank the documents as we have to show the result to the end user, right? It would be like you are giving the ordering, kind of you are showing the results based on the priority or the ranking that your system generates. So this step provides you the ranking. So till now, if the query was this and then we were following the OR operation or the union, then document 1 would have higher ranking as compared to document 2. Okay. But after this, we have another step, which is apply filters. That can be optional because it depends if the filter has been provided in the query or not. But let's say in the query, we were also provided a filter related to price. Say user has said the price should be less than 1 lakh, or you can say price should be less than 100,000. So if we apply this filter now, because we have like both of the documents, if we see, although document 1 till step 4 had like higher ranking, but if you see this filter, it doesn't match here. Okay. The price of this device is more than 100,000. Okay. Whereas when we talk about document 2, the price is less than 100,000. Or if we talk about like price, here you can see is more than the filter amount that we have said. Whereas when we talk about document 2, the price is lesser than the filter amount. So this fulfills the criteria, and that's why document 1 is out due to this filtering and document 2 is in. And next we will have the last step, which is the step 6, where we will sort and return the result. Okay. Of course, the final result depends on the query and the filters that we apply. Okay. If there are no filters, then till step 4, document 1 had more ranking as compared to document 2. So say the query was simply iPhone phone and we were applying the union here. So the end result would have been document 1 and then document 2. Document 1 has the more priority. So the search database would have returned document 1 and then document 2. Now after that, what to show, like it depends on what you want to show. That can be at your backend logic. Like say you simply show the title, then you will return that, and on UI you can bold that kind of text. Or if you have to show both of the things, the title and the description, you can send that. So all those things you can manage at backend, and how to show you can handle that at front end, like bold the characters or whatever. But the search database will basically send you the document IDs. So first it will send you the document ID 1 and then document ID 2. But let's say if the query was this iPhone phone with the union, and apart from that we have also applied the filter like price should be smaller than this amount, then as we saw, the document 1 doesn't fulfill this filter because the price is greater than whatever amount we mentioned, and in document 2 this filter was fulfilled. So In that case, if we say this in union with this filter, then it will only return document 2 because document 1 is not fulfilling the filter. Okay, so it will send document 2 ID, and then of course your backend logic what to show, and on the UI you can make your logic how to show that thing, right? So I hope from this you got the idea. We have mentioned all the steps here. It's not that complicated. You will first try to find out all the words from the query, then you will simply look in the inverted table, you will get the documents in from that, and then you will apply the logic of finding the matching documents based on if it's an intersection or union. And once you have the documents with you, you will score the documents doing the ranking using the metadata. Fifth step would be apply filters if there are any, and in sixth step you will sort and return the data. So this is how the search database stores the data and how it searches for the data. So here we took example of the normal complete keywords, but we also mentioned that the search database is also capable of doing the fuzzy search or even for the partial match. How does the search database do that? It is able to do that using the prefix tree or n-grams. So it is able to identify the partial words using this. Similarly, for the fuzzy search, it can edit the distance and find out the result for you. But let's not go deep into that because more important was like we wanted to understand how it works for normal kind of search things, and we have talked about it. All right, so this is how the complete flow would look like. Okay, user will type the query like we said, this query iPhone phone, so the user will type the query, then the backend will call the search database. Now because the microservice already knows that we have specific database, the search database for these kind of operations, so it will redirect to the search database, and then search database will return the documents and the scores. How? We just discussed all the 5 steps here, right? From this, your search database will return the document ID and the ranking of those document ID or the scores. Okay, now it's up to the backend how it wants to format the response, right? And then on front end it will show whatever it wants to show, and it can also highlight the things, like it can make the search query in the results as bold, right? So this is how the complete end-to-end flow for the search query would look like. Okay, so this was about the search database. After this, let's talk about one more special case, which is time series database. All right, now let's discuss about time series database. Now you might think, hey, wait, you said that in wide column database we can do time related storage. Yes. So what is the difference then between time series database and the wide column database? Don't worry, we'll discuss about it. But before that, let's discuss in detail about time series database. So a time series database is optimized to store and query data points ordered by time. Okay, every record has time as the most important dimension. Some of the examples where time series database would be used are like you have to store CPU usage every second, stock price every millisecond, app request count per minute, or temperature from sensors every 5 seconds. All of these look like corresponding to time, you have the value. So time is the most important dimension here. So if we take example of CPU usage every second, it would look something like this. Time was 10 hours, 0 minutes and 1 second, and we have data corresponding to it, like CPU usage was 60%. Then at next second, the CPU usage was 63%. Then next second it was 61%. So time always increases, and because you have so many writes, so writes are append only here in the time series database. So you are just appending the data. So this thing here, for example, the CPU usage or stock price or app request or temperature, so this is the metric, right? Next, as we said, the time is the most important dimension, so this is timestamp, right? So we have already written timestamp here. So this is a very important part of time series database. So I have created a border across the timestamp because it's a key concept of time series database. So we have metric, we have timestamp. Next, this thing like host or the region, they come under tags or dimensions. So basically in tags or dimensions, we have things like host and region. And then finally we have the value. So these 4 are the core concepts of time series database. First is the metric like the CPU usage. Next we have the timestamp where you have the time. Then we have the tags or dimensions which tell about the host or the region. Then you have the value, like you are storing the value 60%, 63%, etc. So this is how it looks internally. You can see we have the metric as CPU usage. We have tags like host, server 1 as like whatever region it is. And then region provides the information of the region. And then you have the time. Corresponding to time you store the value. For example, like we have this data, so it appears something like this is the time, this is a value. So at second 1 we have 60 as a value, second 2 we have 63 as value, and second 3 we have 61 as value. All right, after this, now let's see how the time series database is different from normal database like SQL and NoSQL. So if we talk about storing this kind of data in SQL or NoSQL database, then you will have too many write operations, because you can clearly see with every second you have new data, correct? So it will keep on increasing as the time always keeps on increasing, right? So you will have too many write operations. There will be huge indexes because you have the indexes for the read queries, right? But when you write, indexes make read query fast, but they make write operations slow, because when you write, you have to write in database, also you have to update the indexes. So the data of indexes will keep on increasing as well. And next thing is you will have expensive deletes, because your data keeps on increasing. Of course you need to delete it as well, so that would result in an additional operation. And another point is, in SQL NoSQL you have slow range queries. Of course, in NoSQL, there is one database, wide column database, in which you can store time series data. But we will discuss about the difference between wide column database and the time series database later. Okay. So this was why normal SQL or NoSQL database is not good for time series kind of data. But now let's see why time series database are good for this kind of data. So they are optimized for massive kind of write operations, because they strictly follow append only. Okay. Next, they are optimized for time range queries. So you can perform time range queries here. We'll see an example later. And it is also optimized for aggregations over time. So based on the time duration, you can do the aggregations here. And lastly, automatic date expiry. So you don't have to deal with the delete operations. So as we said, like time series databases are optimized for massive write operation. So let's see how write operation work in time series database. So in time series database, we perform append only writes. Okay. So whenever you get the new data, it is appended at the end of file. So there are no updates, just the new data is appended at the end of file. So this gives you very fast writes. Next, let's see how data is stored internally in time series database. So the first thing is time based partitioning. So in partition 1 we will have data from time 10 to 11, and in partition 2 we will have data from 11 to 12. So when we talk about the read operations, only relevant partitions are scanned. Okay, because we know, like in this partition we have data specific to this time period, and in this partition we have for this time period. So whenever you get the query, based on the required time, we scan the specific partition. Okay, the second point is it has column oriented storage. So instead of storing it as time, host, value, it is stored as time is this and value is this. So you have column oriented storage. So from this you can directly get this time, and this allows faster scans. So you can clearly see corresponding to time we have the value. So time is the most important part of the time series database, and through this you get like faster scans. Another point related to time series database is that it enables compression as well, because in time series database you have ordered timestamp and similar kind of values. So it uses compression tricks like delta encoding, which stores the differences only, or run length encoding. So based on that it compresses the data. Okay, for example, the data was 60, 61, 62, 61. So it will store the deltas plus 1 and minus 1, because this value is greater than the old value by 1. Again 62 is 1 more than 61. When we talk about 61, it is 1 less than previous value. So like this we are simply storing the deltas. So because we have compression in time series database, the storage is cheap. So these are some of the examples of the query for time series database. For example, average CPU time in last 5 minutes. So you'll do average CPU usage where time is greater than current time minus 5 minutes. Okay. Similarly, max temperature per hour. So max temperature, group by hour. So all such queries are performed for time series database. Another key feature related to time series database is downsampling. So basically it will summarize the old data. Okay. For example, we get the raw data every second, and after 7 days it will form 1 minute average. After 30 days, it will form 1 hour average. So like this, there can be multiple downsampling that can be done, and this saves storage and speeds the query because you already have that information, so the queries will be fast. Now apart from downsampling, we have one more important feature in time series database, which is retention policy. We saw that in normal generic database like SQL or NoSQL, deletes will also be expensive. You have to take care of that. But we have retention policy in time series database, so it will have something like keep raw data for 7 days, keep hourly data for 1 year, delete older data automatically. So basically there are no manual deletes. Time series database is handling it automatically using the retention policy. Okay, now let's see some of the popular time series databases. Because we have discussed a lot about time series database, now let's see some of the famous time series databases. First is InfluxDB. So this is a pure time series database. Second is Prometheus. This is also quite famous and it is monitoring focused. Next is Timescale DB. This is a mix of SQL and time series database. Another one is OpenTS DB, which is built on HBase, is a NoSQL database. And one more is ClickHouse. Okay, so all of these are time series databases. Now come the main question, when should you use time series database? So use time series database when data is time ordered, because time is the most important dimension in time series database. Next thing is when there are lot of write operations. So writes are more than reads. When your data is mostly append only and your queries are time range based, because we saw an example like how the queries look like for time series database, right? So when you have these kind of things, then you should use time series database. Now when not to use time series database, when you have frequent updates, because in time series database writes are strictly based on append only. Okay, and you should not use time series database when you have complex joins. Another thing is you should not use it when you require strong transactions like strong asset properties, strong consistency, which we see in SQL. Okay, so if you require these things, you should not use time series database. All right, we have discussed a lot about time series database. Now let's move to an important question, which is what is the difference between wide column database and time series database? We mentioned earlier that wide column database can be used to store time series data. So then why do we have time series DB? So basically wide column database can store time series data, as we said earlier, but time series databases are built specifically for time series data. Okay, so yeah, wide column database can be used to store it, but this is built specifically for the time series data. So you can think like this: in wide column database like Cassandra or HBase, I can store anything at huge scale, because wide column database is also good when you have massive writes. As in this you have dynamic number of columns and the columns can be in thousands or millions, right? So I can store anything at huge scale including time based data. Okay, so yeah, you can store time series data in wide column DB, but when we talk about time series DB, examples are InfluxDB, Prometheus. So this says I exist only to store and analyze time based data efficiently. Okay, so this is giving you an option. Yeah, you can store time based data as well, but time series DB is specific. It exists only to store and analyze time based data efficiently. Okay, let's try to understand more about it. Okay, so when we talk about like data modeling, right, in wide column database like Cassandra, schema would be something like this. Primary key contains device ID and the timestamp. This is your row key, device 1, and corresponding to it we have the columns, right? So these are the columns and it can contain a lot of columns. As the time keeps on increasing, we can keep on increasing the columns as well. Now the important part to see here, the good thing is time is part of the primary key, as you can see here, and in wide column DB we have data sorted by timestamp, as you can see here. These are the good things, but time is not the first class concept. Correct? So you have the row key and inside that you have the columns where you store the data. right? Now let's see data modeling in time series database. Example is Influx or Prometheus. So you will have something like this. CPU usage is the metric, host and region are tags, and then you have value corresponding to the timestamp. So when you see the data, it would be like time. So corresponding to time, you will have the value. So time is mandatory, central, and optimized at every layer. So this was the difference between wide column database and time series database in terms of data modeling. Next, let's see the differences between both of these in terms of storage engine. Okay, when we talk about like the storage in wide column database, it is based on row key and the family columns or the dynamic columns, right? Corresponding to the row key, you have the column family and then the dynamic number of columns. Whereas when we talk about time series database, it is a combination of columns and time blocks. Talking about the time awareness, it is basic in wide column database, whereas it is native or the most important thing in the time series database. Talking about the write pattern, as we discussed earlier in wide column database, in general it is append, but in time series database it is strictly append. When we talk about compression, it is generic in wide column database, whereas it is time aware compression in time series database. So everything is specific to time in time series database. Talking about retention, retention is manual or TTL kind of expiry that you give in wide column database, whereas when we talk about time series database, it is built in. We saw the retention policy, right? So that is built-in feature in time series database. And lastly, when we talk about the downsampling, it is manual in wide column database, whereas it is built in time series database. Alright, so earlier we saw differences in terms of data modeling. Next, we saw differences in terms of storage engine. Now let's see the differences in terms of query capability. So first, when we talk about wide column database, if we make a query like get last 100 readings for device X, so it will be hard. Few more examples are average over last 5 minutes, group by 1 minute, rate of change. So all of these require app logic and they require Spark or analytics layer. Okay, so apart from wide column database, we would require another layer there like Spark or any other tool which would help in performing all these queries. Next, if we discuss about time series database, if we make query like average CPU where time is greater than current time minus 5 minutes, then it's easy for time series database as it has built-in time windows, aggregations, rates, and percentiles. So many of the things or data related to time is already built in. So it's quite easy for time series database to give result of such queries, right? So these are the differences between the wide column database and the time series database. We saw the differences in terms of data modeling, like how data is stored. Then we also saw like differences in terms of storage engine, what they follow, like time awareness, write pattern, compression, retention. For example, in wide column database, you have to handle the deletes in manual way or using TTL, whereas this is built in time series database, also the downsampling, right? And next we saw the query capabilities difference, right? So if you have to make queries like this, it's quite easier when we talk about time series database, whereas when we talk about wide column database, apart from wide column database, you have to use another layer like Spark or any other analytics layer to help in these query, because it would require some kind of aggregations and all those support which are already built in time series database. Now you may have one question in your mind, like if we have time series database which is specific for time series data, why would companies still use wide column database for storing the time series data? The answer to this question is because company might be already using wide column database like Cassandra. Okay, then instead of using another database specific for particular operation, it uses the same one. Another reason can be it needs extreme availability. Now time series database is good for specific operations related to time series data or querying that part, but wide column database is better in terms of like extreme availability or other features, because wide column database is generic NoSQL database which is used more frequently for primary kind of work, right? So they might be already using it and they would like to just extend the role of current database like wide column database for storing another operation related to time series data, as wide column database can store time series data, right? So instead of using a new one, they just extend the role of the current database. So for that, what they need to do is, like as we saw, they would need another layer like Spark or any other analytics layer to handle the queries like this, correct? So they are okay with writing that aggregation logic or using the tools like Spark or some analytics tool for that logic, right? So that is one additional step, but they feel it is better than using another database specific for some operation, right? All right, now let's discuss in terms of interview. So if in an interview you are given like a high level design question which requires time series data related operations, something like a monitoring system, then you have two options, correct? First one is using the wide column database, which is type of the NoSQL database like Cassandra, right? So how will you handle time series data? It can store time series data, so it can store the raw metrics, and then you will use Spark for aggregations. Like we saw, the wide column database would require additional step because it is difficult to handle these kind of queries for wide column database, right? So we will use Spark or any other analytics layer. Okay, so apart from wide column database, we will use Spark for aggregations. So we will handle deletion using TTL, right? Because deletion part or retention part is not built in feature of wide column database. Okay, or the other option is you can directly use time series database like Influx or Prometheus. So it will store the metrics, the aggregations are built in, the retention is built in, and you would require less code. Okay, now coming to advise what answer to give, like if the interviewer asks you specifically which database will you use. Okay, so it depends, like if your question is very specific to time series data related design, then my choice would be to go with time series database because it shows that you have good knowledge about the databases. Like time series database is built specific for that kind of functionality. So if in your system design interview the interviewer is asking specific question related to time series data and then asking which database will you use, I think better option is to say time series database like Influx or Prometheus, and then you can tell why, right? But as you know, the system design rounds are quite open ended. Okay, so in case you see the interviewer is not aligned with you or the question was bit more generic, like you had to design few components and time series data was just one more operation or another thing that was required here, then you can also go with this option. You can tell you can use wide column database like Cassandra, and then you will use the Spark for aggregation, and then you will use the TTL for deletion. Okay, the good part here is because we are understanding the things here and we are not just remembering, okay, do this, do this, do this. You can explain the logic, right? And that will show that you have good knowledge about the database layer, right? And that would be quite impressive, to be honest, because a lot of people might not even know about time series databases or the name like Influx or Prometheus. So if you tell that, it's a really good impression that you have knowledge of the deep concepts out there, right? So you can say this, but if you see the interviewer is not aligned with you, you can say, okay, what we can also do is like we can use this kind of option where wide column database and use the Spark for aggregation. Okay, but if the overall system is like you need extreme availability, if you need massive writes, and for generic operations in that system also you are already using wide column database, then of course you can put these as additional steps because your current database can handle time series data. Okay, so depending on the question and the situation you can choose between both of these options, but the good part is you know about both of these options and you can tell. So I don't think that will be any problem if you know the concepts, right? So this was about time series database. All right, next let's discuss about another concept which is OLTP versus OLAP DB. Okay, so it's a very famous interview question. What is the difference between OLTP versus OLAP database? Okay, first let's see the full forms of both of these. OLTP stands for online transaction processing. So OL means online, T stands for transaction, and P stands for processing. Whereas when we talk about OLAP, the full form is online analytical processing. So OL stands again for online, A stands for analytical, and P again stands for processing. So clearly the only difference that you see is transaction versus analytical. Rest both have online processing, and the common part is online processing. Just the difference is transaction and analytical. So OLTP is used for your transactions, basically running your business, whereas OLAP is more on the analytical base, like you try to understand the business based on analytics or the metrics, logs, all such things. So first, if we talk about OLTP, the purpose is to handle day-to-day operations in real time. So as you can see, it contains transaction. So the real business it handles. So day-to-day transactions which are happening, it is handled by OLTP. Some of the examples can be placing an order, booking a ticket, transferring money, updating user profile. So all the major operations that your product provides, that is handled by OLTP. So if we talk about some of the characteristics of OLTP, then it's, so in this we will have many read and write operations, we will have short queries, we will require consistency, we will require high concurrency. So both SQL and NoSQL databases that we discussed can be part of OLTP category. So this is kind of a category, you can say. This is not a separate database. These are just kind of categories. So in OLTP, you can say both SQL and NoSQL databases can come, which handle your day-to-day operations, right? So here we have a query example for OLTP, like select star from orders where order ID equal to 101, right? And one more example is update orders set status equal to paid where order ID equal to 102. Okay, so we have already seen such of those queries in SQL and NoSQL, right? And these are fast, these are index based, the result can be single row or multiple rows. So here we discussed about OLTP. Now also let's discuss about OLAP. Okay, so what is OLAP? The full form is Online Analytical Processing. So as you see in the full form, it contains analytical. So this category will be used more for understanding the business, like the analytics, metrics, log, etc. So the purpose is to analyze large volumes of historical data from which you will understand the business, like what's happening overall, correct? So examples can be monthly revenue trends. So you can create some metrics by analyzing all the data and you try to collect monthly revenue trends, or user behavior analysis, through which you'll get an idea like what most of the users are using in your product. You'll get more understanding like where to expand your product, what people are liking, what people are not using, all such kind of things. Another example is sales by region, like which region is giving you most sales, where your product is not doing well. So you will analyze all those things from here. Another example can be average order value per week. So clearly you can see when we talked about OLTP, in the examples we talked about the transactions that are happening, or you can say all the operations which are running your business, like booking a ticket, placing an order. Whereas when we talk about OLAP, here basically we are trying to understand the stats, or we are doing the analysis, how user is using, which region is doing well. So you are just understanding the analytics, the metrics, the dashboards. So you are just trying to understand where your business is going, and according to it you can take more actions. Now some of the characteristics of OLAP, we have most of the operations are read. We will have large scans because you will have a lot of data, right? And you will analyze that large volume of data, so you will have large scans. You will have complex aggregations because you are trying to do all such things here, right? So you will have the complex aggregations, and you will have less frequent queries. Now an example of OLAP table could be something like this. Here we are talking about the sales fact. You can see we have the date, we have the product ID, we have the region, and we have the revenue. But there will be huge amount of data. Okay, so there can be millions or billions of rows here. Now let's see one of the query examples of OLAP. Okay, so here we do select region, and then we do a aggregate operation here, sum of revenue from sales fact. Sales fact was our, you can see the table here, right? And then we say where date is between this and this. So we have given the date range. So we had this field date, and here you can see we have given the date range, and then we have said group by region. Correct. So this is an example query for OLAP. So OLAP queries are generally long running. They have heavy CPU and disk usage, and they have large scans. Okay, now let's see core architectural difference between OLTP and OLAP. Okay, first talking about the purpose. OLTP is used for transactions, whereas OLAP is used for analytics. Clear, because only difference in the full form is also between transaction and analytics, right? Then talking about the query size of OLTP is small, whereas for OLAP the query size is large. Talking about the read writes, in OLTP we have both read operations and write operations. When we talk about OLAP, we mostly have the read operations, because as you have to do the analysis of all the data, right? Talking about the concurrency, it's a very high requirement in OLTP, because OLTP is used for the transactions. Like you have to book a ticket. So say there is only one ticket left and two users are trying to book the ticket. If you don't have the concurrency control there, then both of the users will book that ticket, and that will be a big trouble. Now if we talk about OLAP, the concurrency is moderate in it. When we talk about data size of OLTP is in GBs. But when we talk about OLAP, the data size is in TBs or PBs. So you can understand we have really high volume of data in the OLAP. So because you have all the historical data, and then you have to analyze that. So clearly we are not performing any of updates or delete operation here. We are kind of just appending the data and then doing most of the read operations on that huge amount of data. So the data in OLAP is huge as compared to OLTP. Now when we talk about the response time, it is in millisecond for OLTP, because of course the end user is using your OLTP, correct? Because the transactions are happening through OLTP, so it needs to be fast. It's just like you want to book a ticket. Okay, if it will take a lot of time, the user experience will be really bad and user will not even use your product, right? So it needs to be very small, in milliseconds. But when we talk about OLAP, this is mostly for analytics. Like your developers are kind of using it to analyze the data, to create the dashboards, metrics, which are further used by other people in the company, right? So in this, the response time can be slow, and that is totally fine, because you have to scan a huge amount of data, right? So response time in OLAP is generally in seconds or even in minutes. That's totally fine. It's like a long running operation, and through that you get your data, and it's fine because the user for this OLAP is your kind of developers or other employees in the company, and not the end user. But when we talk about OLTP, the user is actually the end user who is trying to book a ticket or buy a product or something like that, right? So in this, you need to provide the features like very less response time, high concurrency, reads and writes, right? So all those things are provided by OLTP. OLAP, you can take some time in the response time, like even in minutes. Data size is high, concurrency is moderate, because it's okay in that part, because it's not the end user who is actually using your OLAP. So these were the differences between OLTP and OLAP on architectural level. Now let's see the differences in storage format. So when we talk about OLTP, we have row based storage in it. For example, in your row you have the order ID, user ID, amount, status, created at, just like we saw in SQL or NoSQL, right? So when you fetch a row, you get all the data corresponding to that row, right? And why do we have row based storage? Because through this you'll fetch the whole row data fast, and it is perfect for point lookups and updates. Examples are MySQL, Postgres, Oracle, the SQL, or even some of the NoSQL database. They can be used as OLTP. Now when we talk about OLAP, we have column based storage in this. Like for example, here we had all the data in the row. Here we have column based storage. So order ID is one column and corresponding to that you have data. Amount is one column and all the data is in that amount column related to amount. Then region is one column. Now why do we use column based storage in OLAP? Because we have to scan only required columns here. Like in OLTP, we generally try to fetch the row through which we get all the data which is present in the row. But here in OLAP, the requirements generally are specific to one of the fields. Okay. And we store the fields as a column. So basically, when you fetch a column, you get all the data specific to that column only, right? Like here in the row, you would have order ID 1, user ID say 2, amount is 300, status is like anything you can say 200, right? And created at some time. Next row would be some other data. So when you fetch, you get all of these fields for a particular row, because mostly your requirement related to transaction is like that, because you want to know user ID, what was the time, and what was the amount, status, all such things. But when we talk about analytics basis, you generally have the requirements to scan data related to particular column only, and you store as column based. Okay, so you will scan say for amount, so you'll get all the amounts, and through that you will do some aggregation and find out what is in generic your the amount value, the average, or whatever you want to calculate through that, right? Similarly, if you query for region, you will get all the regions, and then you'll get to know which regions you have more business and in which region your business is bit lacking. So because analytics has more requirement or queries like that, so we do column based storage in OLAP. And other points is we can do better compression and faster aggregations in column based storage. Some of the examples of OLAP are Snowflake, BigQuery, Redshift, ClickHouse. Now next, if we talk related to schema, then for OLAP, we have denormalized schema. Like in SQL, you might have seen we tried to normalize the data, correct? But in OLAP, we follow star schema. What is star schema? Something like this you can see. So all of the data would be present together. So we have the fact table, in that you have the region dim, you have user dim, you have date dim, and you have also product dim. So you can see it contains data related to all of the things. Now why is it required? Because as we said in OLAP, we will have most of the read operations, right? And if your data is across multiple tables, then you would require joins. So using this star schema, you will have fewer joins, you will have faster reads, because most of the operations here are read operations, so you want faster reads. So that's why you keep all the data kind of together, and you have simpler queries because you don't have to apply joins here. It will be more simpler that way. Okay, one more important thing here is, as we said, like OLTP is used for your running the business and transactions. So OLTP acts as your source of truth. Okay, but when we talk about OLAP, the data in OLAP that usually comes through OLTP only. Okay, because OLTP is used for your transactions running the business, so it will have the data, and then from OLTP we give the data to OLAP for analytics operation. And how do we do that? We do that using pipelines like ETL or ELT, or you can also use batch or streaming jobs. So here a message queue like Kafka can also be used. So basically you will get the topics here, and then those can be consumed by OLAP. Okay, but we will not discuss about Kafka in this video, because this video is specific to database. If you want to know more about say Kafka, put that in comment section. I'll create a separate video that for you. But I have talked about some of the concepts related Kafka in the system design video. You can refer to this and you'll get more idea. Next, let's discuss why you should not mix OLTP or OLAP. Like why not to use OLTP for analytics and why not to use OLAP for the transactions. Okay, say you think like you can use OLTP for both your transactions and also for running the analytics, then what will happen is like it will slow down the production traffic, because a lot of bandwidth will be consumed for the analytics operation as well, right? And OLTP, say we take example of SQL, so it follows ACID properties, it has strong consistency. It provides good concurrency support, so it will lock the tables and there will be a bad user experience. Okay, and if you use OLAP in running the transactions, then you will have slow writes because OLAP is designed mostly for the read operations, so you will have slow writes. You cannot have proper transactions. Like if we talk about SQL, it follows asset properties, high consistency. In OLAP, you don't get that. And due to OLAP, you will have poor concurrency. So there can be a case two users got a single ticket which was left, and it can create a lot of issues. So overall, as a summary, OLTP systems are optimized for fast concurrent transactional operations. Okay, using the row based storage. Here we have the row based storage, right? And normalized schemas, while OLAP systems are optimized for large scan analytical queries using columnar storage and denormalized schemas. OLTP is used for transactions running your business, while OLAP is used for analytics to understand the business. Now, in modern times, we also have some of the hybrid systems in which some of the database try to do both of the things, like OLTP plus OLAP. Some of the examples are PostgreSQL, which is of type of OLTP. It's mostly a type of SQL, but it can also perform light OLAP operations. Then we also have ClickHouse, which is of type OLAP, but can also do fast inserts. We saw like most of the OLAPs can do are used for mostly read operations, but ClickHouse can also do some of the fast inserts. Then we also have HTAP, which is a hybrid one. It is mixed type, both OLAP and OLTP. But the point is, these are still not ideal for heavy workloads. Okay, so basically, if you are asked in a system design interview question, okay, like if your some operation is related to analytics, then you should choose OLAP category database. Okay, and if you have to perform like transactions, okay, so this was like analytic purpose, and if you have to perform some transaction, then you should choose OLTP category, right? So with this, the interviewer will get to know that you have clarity about these categories as well, like OLAP and OLTP. Like you know when to use OLTP for like day-to-day transactions related to your business, where end user is using the product like booking a ticket, whereas OLAP is used by the developers or other employees in your company to read huge amount of data and to analyze that. Okay, so let's summarize it for OLTP and OLAP. So OLTP DB is like source of truth because it is handling all the transactions, it is running your business. When we talk about OLAP, it is like a copy because we get this data from OLTP only, and this is for analytics purpose. So OLAP is not your source of truth. You get this data from OLTP using some pipelines or some jobs or through message queue topics. Any of the medium, you get that data in OLAP as a copy, and it will be used for analytics purpose. Now, one more thing is like both OLTP or OLAP can use SQL or NoSQL database. Like OLTP, it is very clear because it is used for day-to-day transactions, and we see SQL is used. Some of the NoSQL databases are also used in OLTP. Similarly, for OLAP, some of the databases related to SQL and NoSQL, depending on their properties, how they perform the task, what are their characteristics, they can also be used for OLAP. So these are just kind of categories, but databases, we generally use SQL and NoSQL in these. So here are some of the examples. When we talk about OLTP database, for SQL, we can use MySQL, Postgres, or Oracle. When we talk about NoSQL, we can use DynamoDB, we can use Cassandra, we can use MongoDB. All of these can be used for OLTP. When we talk about OLAP, some of the examples are related to SQL based OLAP. We can have BigQuery, Snowflake, and Redshift. When we talk about column store based, we can use ClickHouse and Druid. For search, we can use Elasticsearch, which is for analytics use, and we can also use time series database like Druid, Timescale, Influx. Okay, so here you can clearly see the two categories that we discussed just before this one, the search database and the time series database, which are a separate category from SQL and NoSQL. These two also are used as OLAP. These two are not used for OLTP because search is specific for searching something. It's not good when we talk about day-to-day transactions, right, running your business. Similarly, time series database is specific to time series related data storage and performing well in those queries. Okay, so both of these, search and time series database, these are good for OLAP and not as OLTP. But overall, in both OLTP, OLAP, you can use both SQL and NoSQL database depending on what features that database provide. Okay, and overall OLAP can be used for like analytics, for creating metrics, dashboards, analyzing the logs, to get the aggregated data, to check the history. So this is the overall flow. So user will use your product via app or the web browser, right? And in this we will use OLTP because end user will perform the transactions like booking a ticket or buying a product. So for that we will use OLTP. OLTP we can use both SQL, NoSQL, like we can use MySQL here, like we mentioned this one, right? We can also use DynamoDB, which is type of NoSQL DB. So you can clearly see OLTP is acting as source of truth here, right? And from OLTP, we will get the data as copy in OLAP. How? We can use the jobs, we can use the pipelines, or we can also use the message queue like Kafka we mentioned here, correct? So from OLTP DB, the events or the topics are present in Kafka and those will be consumed by OLAP DB, and hence OLAP DB will get the copy of data which will be used for analytics, right? Some of the example can be ClickHouse, as we mentioned here. This is column store type. Then we can also have BigQuery, which is type of SQL OLAP, and then root is also one more type which can be of type like time series or column store. Okay, because you have a lot of databases present in both of the categories of SQL, NoSQL, and then also other categories of search DB and the time series DB. All of these databases have their different properties, and based on that they can be used as OLTP or OLAP. Okay, and then using the OLAP, because you have all the history of data here, you can use those to create like dashboards or create the metrics or to analyze things, to do the aggregations and much more. Okay, but mostly when we talk about OLAP, we don't do delete operations or update operations. We just keep on appending the data, so it has a lot of data, and then we just perform the read operations or aggregations on that whole data. Okay, so this was about OLTP versus OLAP, which is a very famous interview question. Okay, all right, now let's discuss some of the concepts which may be asked in the interviews. Okay, so one of those is NewSQL. So basically we discussed about SQL first, right? And then we also talked about NoSQL, correct? So in SQL we get strong asset support, atomicity, consistency, isolation, durability. We have rich SQL queries, we have normalization, we have joins, and much more features. But majorly SQL is used for strong ACID, strong consistency. So that's why it's used for financial transactions, banking apps, correct? But there are issues as well. It is really hard to scale SQL horizontally because it would require sharding, and if your data is present in different shards, when we talk about joins, it will become distributed join. Okay, and across the shards it will be really difficult to maintain acid properties, right? So that's why that sharding logic is handled by app level, and overall the writes don't scale easily, correct? So we have some good things about SQL and some issues with SQL as well. Now when we talk about NoSQL database, the good point is horizontal scaling is kind of automatic feature in NoSQL. These are designed in this way only. So the issue we had in SQL is automatically fixed in NoSQL. So this logic of horizontal scaling is handled at the DB level for NoSQL, which was handled at the app level for SQL. Okay, apart from that, there is high availability, writes also scale easily, but there are some issues. In SQL we got strong ACID support, and that is bit of missing in NoSQL. Okay, so we have weak transactions, eventual consistency. Talking about consistency, we had like strong consistency in SQL, but in NoSQL we have eventual consistency. Next thing is, as we saw in SQL, it is designed like you have different tables and which are related to each other via foreign keys, and because you have to interact with different tables, joins are there in SQL. But NoSQL is designed in such way to give this feature of horizontal scaling that there is weak or no support for joins in different types of NoSQL databases. So we can clearly see there are some good points in SQL, but there are some limitations as well. Similarly, in NoSQL, there are some good points, but there are some limitations as well. So NewSQL provides the positives from both SQL and NoSQL. So we will get strong ACID properties support from SQL and easy horizontal scaling from NoSQL. So NewSQL is a combination of good properties of SQL and NoSQL, hence the name becomes NewSQL. Now let's see what are the things that NoSQL is trying to fix. Okay, so first talking about the SQL support. In old SQL, of course, we get that's a main feature, right? But talking about NoSQL, we don't have that SQL support. In NewSQL, we get that support. Okay, so it has picked something from SQL. Talking about strong ACID support, in old SQL or normal SQL, we of course have that because that's a main property of SQL. In NoSQL, we don't get that support, but in NewSQL, we get that. So another thing that is picked from SQL. Now talking about horizontal scaling, in SQL this is an issue because of all the reasons that we discussed. In NoSQL, horizontal scaling is quite easy, and in NewSQL, horizontal scaling is easy because it is picked from NoSQL. So earlier 2 points were from SQL. This one NewSQL picks from NoSQL. Similarly, when we talk about distributed system, like it is quite related to horizontal scaling, so it is same as the above one. And strong consistency is what we get in SQL, it is missing in NoSQL, and NewSQL also provides it. So you can clearly see NewSQL picks some of the good properties of SQL and some of the good properties of NoSQL. Then we mix both of these to form NewSQL. Alright, now let's see some of the examples of NewSQL database. Okay, so first we have Google Spanner, then another example is Cockroach DB, then we have TIDB and much more. Okay, so you can just remember one or two examples of NewSQL database. Same is for other, like when you talk about SQL, you should know one or two examples of that. Similarly, when we talk about NoSQL, we had 4 categories, right? Key value, document based, wide column, graph. So you should know like one or two database example for all of these. So similarly, you can remember like Google Spanner or Cockroach DB as an example of NewSQL database. Now a question may come into your mind. We said that NewSQL has the good part of SQL as well as NoSQL. So the question is, why not always use NewSQL? The answer is NewSQL provides you features of both SQL and NoSQL, but you have to pay for that price in terms of cost, latency, and complexity. So NewSQL provides you support of strong consistency, but the trade-off is higher latency. So let's discuss more about this higher write latency part. So when we talk about traditional SQL, it is formed in a way that you have single node. Okay, when we talk about NoSQL, there are multiple nodes and it handles it in a different way. Basically, we'll do replica async, which means asynchronous way. Okay, in NewSQL, in order to provide support for both SQL and NoSQL, it becomes even more typical. So in NewSQL, as there are multiple nodes, so it would need multiple nodes to agree, and each of the write takes more network hops. So overall, the write latency will be higher in NewSQL. Now going to the next point, the benefit is auto sharding, right? Which is picked from NoSQL, because in NoSQL we have automatic horizontal scaling as that logic is handled at the DB level. Okay, but the trade-off is we have complex internals. So the answer to this question is, although NewSQL provides you great benefits, some from the SQL and some from NoSQL, but with that there are some trade-offs as well. There is higher latency, we have complex internals, expensive writes, and the operational cost is quite expensive. So you can clearly see, of course there are benefits, but at the same time there are trade-offs as well. So it totally depends on what you actually want in your system, and based on that you can pick, because it's not a good idea to pick NewSQL for every operation, because that would result in higher latency, complex stuff, and a lot more increase in expenses. correct? So if your system can be handled by SQL or NoSQL, so of course you will go for that. In case you really need new SQL, then of course you can go for it. And as I told earlier, in the system, as you have different features that you provide in your complete product, so there is no such requirement that you have to just use single database. You can have multiple database, okay, depending on what feature you are providing. Based on that, whichever database is best for you, you can choose that. So your complete system can have multiple different databases, okay? So based on what requirement it is, you can choose SQL, NoSQL or NewSQL. Now that I have mentioned that we can have multiple database, so let's discuss a bit on polyglot persistence. Now the basic question would come, what is polyglot persistence? So this is not a database feature, it is more like a core system design mindset. Now what polyglot persistence means is you can use multiple databases in your same system, okay, and each one of these will be used for a specific problem. So as we discussed, like we have SQL, we have NoSQL, we have Elasticsearch, we have time-based database, and we also have NewSQL, correct? So in your system, you can use multiple databases because your system provides a lot of features and functionality, correct? And depending on what problem you are trying to solve, you can choose a specific database depending on the requirement. So for the same system, we can have multiple different database used in it. Now the question can be, why do you even need polyglot persistence? Answer to this is, as we saw, SQL provide different features, but there are some issues with it as well. Similarly, NoSQL provides some good features, but there are some issues. When we even talked about NewSQL, it provided the combination of good features of SQL and NoSQL, but again, there are some limitations. So every database is optimized for something, but it is also bad for some other thing. So in your complete system, you may have different features, correct? And based on all of the features, there can be a case that a single database is not able to fulfill the requirements of all the features, correct? So in that case, we will choose the database specific to the feature, correct? If a particular problem is not getting solved by your current database, you can of course use another database to solve that problem, and keeping the old database in the system as well, as it is working fine for rest of the features. So in technical term also, we can say different data has different access patterns, and that would require different storage. So we can imagine something like this. You have your front end, correct? It can be your mobile application or your web development where user is using the browser, correct? And from front end, you want to interact with backend, correct? And that happens through APIs. If you want to know the basics of system design, how things work, you can refer to this video, you'll get the complete clarity. Okay, so this is your backend, but here is your database part, and you can see you can have different database for the same system. You can use SQL for some of the features where strong ACID properties are required, and for some other features where you see a lot of writes happening, you need horizontal scaling, you can use NoSQL. And then if you have a feature where you have to perform search operation like product search in Amazon, so for that search database you will use. And similarly, if you have to do some time series data based analysis, that can be for your metrics, dashboards, collecting logs, so you can use time series database for that. Apart from these, if in your system you require handling time series based data, like for example the click events on advertisements, you have to track those, so maybe for that you can use time series database. So these would come into your OLTP because these are for your major transactions which are handling the business. And then you can also have OLAP related, which is more for analytics. So OLAP also you can use like to checking logs, you're collecting all the logs, right? For dashboards, metrics, so all that you can have, like you have single complete system, but in that you can see you are using multiple different databases, and that is this concept polyglot persistence. Now let's try to understand this scenario with simple examples. Okay, like just imagine you have a system like Amazon. Okay, so of course you have user related information and they place orders, correct? So when we talk about orders, it is kind of like you are making financial transactions, so you require strong ACID support, correct? So for that you would either use basic SQL or just in case you require, you can use NewSQL. But most probably, I think he'll go for simple SQL here. Why we need SQL here? The strong asset support we need for financial transactions, because we need strong consistency here. We cannot do something like this: user has made the payment, so money deducted from user's account, but order got cancelled. So in this case, you can see user is also not getting the product and money is also deducted. Of course, you will find a way for it, but it can get really frustrating for the end user. So in order to make a smooth user experience, we want strong asset support here. So that's why we would need SQL database here. Next feature can be product catalog. Now you can imagine there are a lot of products out there, correct? And each of the product may have different features, correct? When you talk about television, there are different properties related to television. When you talk about mobile phone, it has different set of properties. When you talk about washing machine or your microwave, it has different properties. So if you use like SQL here, it can become really difficult. Why? Because in SQL you have like fixed kind of schema, but here you can have different properties as per the product. So here we would like to use the document database, which is type of NoSQL database. Why? Because as I said, it will provide you flexible schema. Okay, so you can clearly see just for these two features we have already used two different types of database. So that is what we are discussing in Polyglot Persistence. Okay, next, of course, you would have the product search, because you have so many things to sell. So of course you should provide the feature of search, otherwise how would user reach to specific product, correct? So for search, you neither use SQL nor NoSQL, correct, as we discussed earlier. So in this you would use search DB because it is much faster. It uses inverted indexes, and here you using the search index, you can also do fuzzy search, partial search, rather than just comparing the exact word, correct? So here you can clearly see we are using another separate DB. So for inventory counts also we can use NoSQL. We have already discussed about NoSQL here. Next, if we talk about click events, say you have to capture the data related to click events so that you get the complete understanding like what most of the users use in your product, and it can also be related to some of the advertisements, correct? You get paid based on the click rates, correct? So you need to have that data. So it is time sensitive data, correct? So you can use time series database for this, which is specific to time series related operations, correct? But of course, if you are already using say wide column database, you can use that, because in wide column database also we can store time series database. But of course, time series database is specific for this, so it is even more efficient and optimized in terms of time series related data, correct? So you can clearly see we have another category now. And when we talk about analytics, because like you have such a big complete system, you also need all the things like you can see the logs, so you have to store all the logs, so you have huge amount of data in that. So for that you would use OLAP, correct, related to analytics, where you can perform aggregations. This is useful for checking the logs, dashboards, metrics. So clearly you can see in your system you have different features, different requirements, and based on that you select different database. And this is what Polyglot Persistence is about. Okay, now let's see how data flows between databases, because now we have said that we can use multiple database for in the same system, right? So we also need to know how data flows. So basically SQL or NoSQL, they act as your kind of primary database, because these are used for running your system. These are taking care for the transactions. So once you have the data in SQL or NoSQL, which is your OLTP, which is handling all your transactions, correct? Then after that the events or topics are now present in Kafka, or you can say CDC. So CDC is a kind of mechanism which says like which picks any differences, new changes, you can say whatever has happened in the database, and picks the changes, and then through that it can use those changes, correct? So either through Kafka or CDC or some pipelines or some jobs, through that this data will also come to OLAP related database. Now in OLAP we handle the things related to analytics, correct? So for analytics operations, OLAP comes. Even the TSDB, that is the time series DB, or the search DB, they are also part of this category OLAP. So OLAP gets copy of data. The source of truth remains SQL or NoSQL, which is your OLTP. Okay, but the main point is data is written once. It's not like you have to write data in all of the different databases. So data is written once, but it is read differently everywhere. Okay, so we are not talking about Kafka or CDC in this video, but if you want to know more about Kafka, put that in comment section. I'll create a separate video on that. But in short, if I have to tell, Kafka is like you can create the events or topics in Kafka. Okay, and it is like the event is published here, and now from Kafka multiple consumers can consume the event. Okay, and each of the consumer can consume at its own pace or rate. So it is totally fine if you have one event present in Kafka and one of the consumer consumes it now, another consumer consumes it after some time. Okay, that's totally fine. And in Kafka you can retain your data for like multiple days and even for weeks. So 7 to 30 days you can say the data remains retained in Kafka, so which is long enough duration, and during that time all of the consumers can consume those events. So you can just imagine when the data is written, events kind of created in Kafka that would stay there for like 7 to 30 days, and different consumers like OLAP, which can be used for analytics or even for search related operation or time series related things, all that consume that event from Kafka at their own pace. Okay, so that's why we said data is written once. All right, but now as we are using multiple database, one question that may come would be regarding the consistency. Correct, so how about the consistency, because we have multiple databases. So what happens is like we have strong consistency within a database because we have multiple DBs, right? So within our database we will have strong consistency, but there will be eventual consistency across DBs. Correct, so similar to what we discussed here, when you make a write operation in your OLTP like SQL or NoSQL, of course there will be strong consistency in it, but that data won't be immediately visible in OLAP related database. Correct, so that would come after some time, right? Because this has to consume the events from like Kafka or CDC, that would take some time. So there is eventual consistency between the different databases, but when we talk about the specific database, there would be strong consistency in that database. Okay, so for example, a user placed the order. So because we were using the SQL database for orders related thing, because it required the financial transaction, strong asset support, strong consistency, right? So that would be immediate. Okay, strong consistency in that database where you are performing the operation like your OLTP DB, right? But when we talk about search index update, that would be asynchronous because that is part of like this OLAP. Correct, search DB. So that would happen in some time. So in that way there is eventual consistency between the databases, but when we talk about the database where the transaction happened, there will be strong consistency in that. Okay, and similarly other OLAP related operations like analytics update, that would also take some time. Okay, and that is totally acceptable, right? Because when we talk about analytics like logs, metrics, it is totally fine if it is getting reflected after some time. So eventual consistency is totally fine there, but eventual consistency is not fine when we talk about like user has placed an order and we are saying we are not showing anything to the user. It can create like anxiety to the user, like what happened because my money got deducted and I don't see like order getting placed. So where is my money, will I get my money back or not? So that is a very bad user experience. So you want to handle that thing properly. Okay, okay, one more thing, like when I said like data flow, it doesn't mean that each of the database will have the data, because that's not what we want. Correct, like for example, if you are using both SQL and NoSQL, okay, both of the databases, for one of the feature that you're providing you will have your SQL, and another feature you may be using NoSQL. So there is no need that the data which is present in SQL should also go to NoSQL. No, that is not any requirement here. The good part of this complete logic of using multiple databases is that you don't need to share the data, and because the different data would have different needs, and that can be handled by different DBs. So it's not like the data will go to all of the databases. In this example it happened because like OLAP databases of course take the data from the OLTP ones only, because the work of OLAP is different from what we have in OLTP, correct? So it gets like copy of data from that, but it doesn't mean at the same time that all of the data should be flowed in all of the databases. That is not the requirement. So overall, the meaning of polyglot persistence is that because in the complex system you may have multiple different features, and each of the feature may have different requirement because the data is completely different. So instead of forcing one database to handle all those different kind of scenarios, we can pick different databases in the same system that can handle the specific features in more efficient way. So some features like payment or purchase of products, you need strong asset support, you can use SQL. For search you need like search DBs. For time series data you need time series databases. For like product catalog or high horizontal scaling you need high writes, you can use NoSQL database. So in that way you get like flexibility to use the best database based on your requirement of the feature. All right, so till now we have talked a lot of things related to database, all the concepts we have covered, but now let's talk in terms of interviews. So if you are asked a question related to high level design or HLD in interview, it's generally that you will be asked only one question, okay, and you have to spend like 40-45 minutes on discussion of that specific high level design question can be something like design Instagram or design WhatsApp or design tiny URL or design Google Drive, anything like that, right? So in that you have to talk about things like what all components would be there, like the microservice, the message queue like Kafka, the APIs, and apart from all these, you also have to talk about the database. Which database will you use for this? And when you tell the database, of course, you should also have the reasoning for that. Why did you choose this specific database? Okay, so now the question is, which database will you choose for, say, WhatsApp, or designing YouTube, or designing tiny URL? Let's talk about it. So the first thing is, as we just talked about polyglot persistence, which means same system can use multiple databases. In similar way, when we talk about big systems like Instagram, YouTube, WhatsApp, they can also use multiple databases as the system has multiple features. Let's first talk about Netflix. So in Netflix, if we talk about user profiles and subscriptions, because you have to take the subscriptions and of course the user profile using the login or sign up flow. So for that, we will use SQL database. Why? Because for user profiles, you have structured data, and for subscriptions, you would require strong asset support, billing correctness, which means you would require strong consistency, and that is provided by SQL database. If we talk about the next feature, which is viewing history or viewing recommendations data, for that we would use NoSQL. Inside NoSQL, we have four categories: key value, document base, wide column, and graph. So here we would use wide column database. Why? Because this data will be at huge scale, because you have to show the option of history and recommendations to all of the users, and there will be massive reads and writes. So because huge scale and massive writes, so instead of SQL, we prefer NoSQL here. And because there can be massive writes as well, so wide column is good in that, as the data may keep on increasing, okay? Also, as we can keep all the data in one place, so there would be no need of joins here. So wide column database is good for this feature. Next, if we talk about search related functionality, because in Netflix, you would search for movies or some specific shows, right? So for that, we will use search database like Elasticsearch. Why? Because this is text search, and in search we also want things like partial matching or fuzzy matching or searching inside the sentence. So all those things are part of the search functionality, and for that search database is really good. Also, as we saw earlier, search database provides you ranking and filters. So that's why for search feature, search database is the best. Now these are not just specific to Netflix. If any other system is also using, like you can say, user profiles, then you can simply use SQL there. You already know the reasons, right? Similarly for search, if it is any product like even Amazon or YouTube, for search, now it's like fundamental for us that we will use search database like Elasticsearch there. So after Netflix, now let's see which database will we use for Amazon. So the first feature if we talk about is related to orders and payments. And for this we will use SQL database. Why? Because from the beginning we mentioned that SQL provides you strong asset properties support, also strong consistency, and it is used for financial transactions and payments. Okay, so of course we would use SQL here. A very simple example that we discussed earlier as well. So if user has made the payment but the order got cancelled, using the asset support, the atomicity, the all the operations which got succeeded will also be rolled back. So in a transaction, all of the operations will be either successful or all of those will be rolled back, right? So that kind of feature we require when we talk about payments or financial transactions. So that's why we will use SQL here. All right, next, if we talk about product catalog, as we saw earlier in example as well, we would use document database, which is type of NoSQL DB in this. Why? Because different products have different attributes. And in document database, you don't have any particular schema. You can simply keep all of the data related to a product in one single JSON. Like for example, TV would have different features and microwave would have different features. So the flexible schema of document database is really helpful when we talk about product catalog. Next, let's see what we will use for inventory count. So again, for inventory count, we will use NoSQL database. Now we have two options. Either we can use the key value database or the wide column database. If two choices seem confusing to you, you can simply say wide column database. Why? We would have the fast updates and we would have high availability. And next feature, if we talk about the search, it would be same as what we discussed for Netflix. We would use search database. So as I said earlier, it is not specific to Netflix. Whenever you have the requirement related to search, you can simply use search database. Now let's see which database can be used for designing Facebook or Meta. So the first feature of Facebook is the friends or the followers, right? Because famous is all about networking. So for this, we will use graph database, which is part of NoSQL database. Why? Because this network related to friends, followers, friends of friends, this is relationship heavy, and graph database is based out on the relationships, right? You have nodes and edges, and both edges and nodes can have the properties. Now you may also say like SQL is also based out of relationships, right? You have multiple tables and they are related to each other via foreign keys, correct? But here if you have to calculate friends of friends of friends, something like that, it will require a lot of join operations when we talk about SQL database. But in graph DB, it can be done directly and quite easily. So we would have fast reversal using graph DB. All right, the next feature is feed data. The user feed that you see on your Facebook or Instagram or Twitter, you can say the people you follow, you can see any of the posts that they have created, correct, on your feed. So for this we will use NoSQL database, as NoSQL has 4 categories. So here we will use wide column database. Now why are we choosing wide column database here? Because there will be huge write volumes. Say you might be following 500 or 700 people or even more than that. So that data will keep on increasing, right? And you might have seen in the user feed, the data is sorted based on the timestamp as well. So you see the latest data first and then you can see the older data, correct? So if a person whom you follow, if that person has made like 5 posts, okay, so in your user feed you will see the latest post first, then after that second latest, and in that order you will see the all of the posts, correct? So as there is huge write volume and time based data, so we can use wide column database here. As we discussed earlier as well, wide column database can be used to keep time series data, right? So that's why wide column database is a good choice when we talk about feed data. Now this is not specific to Facebook. This can be used whenever we talk about the user feed. It can be in Instagram, it can be in Twitter or any other place. Okay. Next, if we talk about messages, because Facebook has Messenger as well. So for that we will use NoSQL database. Why? Because messages are on massive scale. On daily basis, there are like millions of messages. So you can imagine the huge amount of scale required. So in this case, NoSQL is much better, because when we talk about horizontal scaling, it is difficult in SQL, right? Now, which NoSQL we will discuss when we talk about designing WhatsApp, because in that also we have to take care of messages. Okay. So overall, in interview, when you are asked high level design question, of course, it is not possible to design the complete system of Facebook or YouTube or Netflix or Amazon in like 40-45 minutes. Generally, you get like a specific feature to build. Like for example, you may be asked like design user feed in Twitter, right? So, or you may be asked like design Facebook Messenger. Okay. You will be asked a specific feature and you have to discuss on that part in 40-45 minutes. So based on that, of course, you would say only this database if you're talking about user feed, correct? But the good part is here I'm discussing mostly all of the features. So you would have idea, okay, if this is the thing, this database can be used, this is the thing, this can be used. Okay. All right. So after Facebook, let's discuss about which database will be used in Google Drive. Now, basically in the beginning, we discussed about the database versus file storage, and I mentioned like if we talk about images or videos, such kind of assets are stored in the blob storage instead of the database, because blob storage is cheaper than the database, and the CRUD operation support or the indexing support that is provided by database is not required that much for images or videos. So for images or videos, the blob storage or the file storage is better as compared to the database. The file storage, you can just imagine it as like the disk storage, like you store things on your disk on of your laptop, right? But when we talk about a file, as we said, like images, videos will be stored in the file storage. It can be something like S3, Amazon S3, but there will be also metadata related to that file, and that we will store separately. Let's talk about it. So first, if we talk about file metadata, like the name of the file, the size of the file, the type of the file, who created this file is shared with whom, all of those things are part of file metadata. And for that, you would generally use SQL database. Why? Because the file metadata is generally structured. So here we have factors like hierarchy, consistency, permissions, and for that SQL, the structured schema or data, is totally fine. Okay, after the file metadata, we have the file storage, because we have to store the images and videos. And as we discussed, that will be stored in like Amazon S3, which is file storage, and not in database. So for this, we are not using database, we are using file storage. Why? Because images, videos are quite large in size, and file storage is cheaper as compared to the database. And another thing, like database provides much more features related to CRUD operations and the indexing, but those are not that highly required for images or videos. So that's why file storage is much better when we talk about images and videos. Then if we talk about searching, it would be same like we discussed earlier. For searching, we will use the search database like Elasticsearch. Searching will be used to search the file name or to search the content. All right, so after this, let's discuss which database will be used to design WhatsApp. All right, the most important feature of WhatsApp is of course the messages, because it is used to send the messages as the main feature. Of course, it provides many other features, but main features is like the messages. And for this, we will use NoSQL database, just like we saw for Facebook Messenger, but we did not discuss what kind of database. So here we are saying we will use wide column database for the messages in WhatsApp. Why? Because first thing, massive writes, right? As I told earlier, in a day only there will be millions of messages, correct? So there is a lot of data and there are a lot of write operations. So for huge number of writes, as we discussed earlier, wide column database is quite good, because the columns are dynamic. You can keep on adding the columns. You can have thousands or millions of columns in a row key, correct? Another important part is because the messages are based on the time, correct? And wide column database can save time based data, so we get the time ordered data. So that is why wide column database, which is type of NoSQL database, can be used for messages. One of the famous example which can be used is HBase database is used, which is type of wide column database for WhatsApp message. Next thing in WhatsApp, if we talk about user profile and auth. We have already discussed about it in the Netflix example, right? So same as we said earlier, for this we will use SQL database. Why? We need like strong consistency in authentication, and user profile is quite structured schema or data, and that can be handled by SQL. Okay, and overall the data related to user profile is small, because when we talk about messages, you have so much data and it keeps on increasing in such a big pace. But when you talk about user profile, the user profiles are still limited, correct? So it's a small set of data, and for that SQL is totally fine. And then the schema is fixed, strong consistency, strong asset support. So SQL is good when we talk about user profiles and all. Now next, let's see which database will be used to design Google Maps. So the first feature if we talk about is location and road data, because you would require all that data, and for that we will use graph database, because there are a lot of connection. So you can see a lot of nodes out there and edges which connect to those nodes, and you can tell the properties for those nodes and edges. And apart from that, you can also use some custom special database, because you have to store location and all those details. But graph database can be used because you can clearly see nodes and edges connecting those, and you have the properties for that. The reasoning can be roads are like graphs, and routing is similar to the graph traversals, like finding the shortest path. So all those things maybe you might have already read while you were studying the DSA, or you might have also solved some of the questions. Like graph has all those special algorithms. Next, talking about searching places, because it is related to searching, of course we will use search database. Then if we talk about traffic data, for that time series database can be used, because we want time based updates and we want to perform aggregation operations. So for that, time series database is the best. All right, next let's see which database will be used to design Google Ads or click advertisements. One of my friends was asked this question related to Google Ads and the click, like which database will you use for this click events, correct? And in this system design round, I think he gave a lot of good answers, but the database part, he wasn't able to give the correct answer and he didn't get the offer. Okay, so you can see the value of this video. I'm telling you, for all of the systems, what kind of database can you use with the reasoning. Okay, so this can be really helpful and it can help you crack your dream company offer. Okay, so make sure you like this video, subscribe to the channel and share it with your friends and family. All right, okay, coming back, first talking about ad serving. Okay, for this we will use key value database, which is a type of NoSQL database. Why? Because we need ultra fast reads and we need low latency, like which ad to show. Okay, so this is the feature which was asked to my friend specifically, which database will you use for click tracking. Okay, the good answer I would say here would be time series database. Okay, and if you're saying NoSQL database, you have to specify which NoSQL database. We discussed about it, right? We can use wide column database, because that can be used to save time series data, but that cannot do the aggregations or some kind of operations that are required for time series related data. So if you are saying NoSQL, first you need to elaborate that. You have to tell wide column database, and you can tell an example of wide column database as well, which you can use. But apart from that, you will also have to say you will use the Spark or any other analytics job or pipeline through which you will perform the operations, like the aggregations or the operations which are required for time series data, which we discussed earlier in this video, right? Like the difference between wide column database and the time series database. Okay, and I told you in interviews you can choose like which option. I gave you two options, right? And based on that you can tell. When you're talking about wide column database, then you have to use additional layer of Spark or any other analytics related tool, correct? So it totally depends on the interviewer. If interviewer wants to listen more on time series database, because we are specifically talking about click tracking, you can go with this one. Okay, this makes more sense. But if you're already using wide column database, then you can keep on using wide column database. Alongside that, you would require a Spark or analytics related tool to handle other operations related to aggregations, right? But we already discussed both of the options. So if you know your choices, you can tell it properly, and interviewer also will get to know, okay, you know things. It's not just you are like remembering things and just saying those. You have your logic. Why will you use this or that, correct? So time series database, the better choice here because we are specifically talking about this feature. Other option is using wide column database, which is type of NoSQL, and alongside you have to use Spark. Okay. Now, why I said these? Because first, for click tracking, there is huge amount of data because a lot of clicks happen, correct? And this is time based analytics, so it is also, you can say, time critical kind of data as well. So these are the best choice for that. Next feature, if we talk about reporting, then as we discussed earlier, dashboards, logs, metrics, we use OLAP database because OLTP database are used for running your business, handling the transactions, whereas OLAP database is used for more of analytics, handling dashboards, metrics, logs, more on, you can say, development side to understand the business, correct? So because reporting comes into it, so yeah, we'll use OLAP database. All right, next let's see which database will be used to design YouTube. Now, similar to what we discussed in Google Drive, in YouTube also we have videos, right, and thumbnails, which are images. So same as like Google Drive we discussed, all those things which are heavy like images, videos, those will be stored in file storage like Amazon S3 and not in database. But of course we also have the metadata related to the file, like the video metadata, it will be stored in SQL because most of the data is structured, so you can use SQL for that. Other option is document database as well, like if you want like more flexible stuff, but I think we don't need to make it over complicated. Let's keep it simple. For metadata you can simply use SQL because earlier also we talked about it and we used SQL. So I mean SQL is totally fine for metadata. But of course if you see like there is huge amount of data and we don't want to go into sharding that much, then of course if the scale is too high you can go for NoSQL database. But yeah, I mean SQL is totally fine. If you say SQL, I don't think there would be any issue in this. Okay. Talking about the next case of comments and likes. So we would use NoSQL database for it because there will be huge number of like comments or likes. Like for example, for a particular video, you get so many likes, right? So we have to keep the data. So there is huge volume and it is like event like data because it keeps on changing, right? So for that we will prefer NoSQL database. Next we have search feature in YouTube, and of course we have already discussed we will use search database. There are also other features in YouTube, but I think some of those will match to what we have already discussed above, and the same database you can use for YouTube as well. All right, next let's discuss which database will be used for designing tiny URL. So the famous feature of tiny URL is that from the long URL you generate the short URL, and when you enter this short URL you will be redirected to the long URL, correct? So we need the short code mapping, and for that we will use key value database again because it's simply like you have the key and corresponding to that you have the value. And why do you use that? It is very fast, so it can handle like extreme scale and that too very quick. So there is simple lookup as well because you'll simply pass the key, which will be your short code, and you can simply redirect to the long one, correct? So for this we will simply use the key value database. There are other features in tiny URL as well, but I think most of the things we have already covered, so that can be used in similar way for tiny URL features. Next, talking about which database will be used to design Leetcode. So the first feature in Leetcode would be related to users and submissions. You can submit the code, right, for the users and the submissions, and for that we can simply use SQL because it is like relational data and we want consistency in it. So basically you can get the information related to the user which you show on profile. So in that you can also see like submissions and all that data. So because that is kind of structured data, relational, and it requires consistency, so we can use SQL there. Next, talking about the problem content, because you see all the problems on Leetcode, right? And then you solve that problem. So if you talk about content of the problem, for that we can simply use document database because each of the problem can have different kind of content, and document database provides you huge amount of flexibility, correct? So for this reason we can use document database, which is type of NoSQL database. Next, if we talk about searching the problems, again because it is related to search, so we will use the search database like Elasticsearch. So after this, now let's see which database is required to design Tinder? First feature, if we talk about the user profiles. Now for user related data, mostly we have said like SQL can be used, but here in Tinder you can provide different details for the profile, and in order to make flexible profile, you may choose document database, which is type of the NoSQL database, which provides you huge flexibility. In one JSON you will have all the information related to the user, correct? So you can put it that way. But if it's like the simple user profile information which has like structured data, then of course you can use SQL database like we used earlier. So it depends what kind of flexibility do you provide in your user profile information. If it's like generic fixed kind of schema, then SQL is totally fine. If it is like very flexible data that you can keep on adding or add more details, then you can use document database. Next, if we talk about matches and swipes, right? Because we have like left swipe, right swipe, and matches and Tinder, correct? So for that you can use graph database because it's more about like relations, correct? And it is easier to handle that in graph database, as graph database also provides you kind of fast traversals between the connections. There are nodes and there are edges with properties, and then you have the algorithms which you can apply to find out the fastest way using BFS or DFS or any other further algorithms which can be used in graph database, correct? So relationship based and fast reversal, so you can use graph database for matches and swipes. Next, as we have recommendations in Tinder, so for that we can use NoSQL database plus ML systems. So we would require machine learning because recommendations is something like you analyze the data and based on that you provide the recommendations, correct? We would also require machine learning systems here, but apart from that normally you can use NoSQL database. Okay, after this let's discuss which database will be used for payment system. I think you already know this because we have talked about it multiple times. For financial transactions, for banking apps, we always prefer SQL because it provides strong asset support and then strong consistency, correct? And apart from that we also require audit and compliance when we talk about payment system, and that can be provided using SQL database. Next, if we talk about analytics related operation in payment system, for that we can simply use OLAP database, correct? Because OLTP database are used for handling the transactions for running your business, whereas OLAP is used for analytics to understand the business, correct? So for analytics, metrics, dashboards, logs, you can use OLAP. Okay, after payment system, let's see which database is required to design the ticket booking system like Bookmyshow. So you have to book tickets for movie or some events, right? So which database to use? So first, if we talk about users and bookings, we would use SQL because as we already discussed about the transactions, and apart from that it also provides the support for locking, correct? So we saw in SQL in order to provide the isolation, correct? So where multiple users are trying to book the single kind of ticket, so you can do it either via locks or the other was creating the different versions, correct? So that's why SQL is good when we talk about like bookings. Okay, next talking about the seat availability, because say a user is already making the payment for one of the seat, correct? So it should not be visible to any other user because otherwise the other user will also be basically trying to book the ticket, and that would cause issues or bad user experience, correct? So you generally what happens is like once a user goes to the payment flow, so that ticket looks like blocked for now, kind of booked, but just in case it fails after some time, that is shown again, right? So that kind of stuff of seat availability, that can be handled by SQL plus cache. Now we haven't discussed much about cache here, but we discussed about key value database in NoSQL database. So for that key value database, one of the example was Redis. In similar way, Redis is also used for cache, and it is quite famous or popular, and it is used on in most of the companies, right? Redis. So why this is required? Because of the isolation problem that we want to solve and the best user experience. Of course I can't discuss about the complete design here because we are focused on the database here. I'll create a separate video on the high level design of booking a ticket on platforms like Bookmyshow, correct? So, and through that you'll get more clarity, but of course for now we can say it's SQL plus the cache. And why is that? Because strong consistency and the ACID properties that SQL provides. And cache here is used for faster access and to simplify the design, which we will discuss when I create a separate video on high level design for booking tickets on platform like Bookmyshow or any other. All right, so we have seen the database used for different systems, but here comes the best part now. I am going to share with you a cheat sheet which can help you to identify the correct database, right? So first, if we talk about financial transactions, money related things, for that we'll use SQL because we need strong ACID support and strong consistency. Next, if we talk about the searching case, like if you want to search product, you want to search events, anything else, for that we use the search database because it provides you the support of like partial search, fuzzy search, searching in the complete sentence, and much more, as it uses the inverted index approach and many other things that we discussed in search database. Now when we talk about events or any data which is at huge scale, correct, so for that we'll prefer NoSQL. Like for example, we talked about messages, correct, so there are huge number of messages every day, so for that it's difficult to use SQL because we already know it's difficult to horizontally scale SQL, correct, so for that we'll use NoSQL database. Next, when we talk about time based data, for that if we talk specifically, we use time series database. Another option is, as we discussed earlier, can be the wide column database plus the Spark or any other analytics tool, correct, but more specific, if we talk about time based data, we can use time series database for that. Talking about relationships like friend of friend of friend, or like in LinkedIn you have like connection of connection of connection, you also see second connection or third connection, like that. So graph database is used for that because you have nodes and you have edges, and both nodes and edges can have some properties having the values, so it makes relationships quite easy. And then as we know, in graph we can use BFS, DFS and other algorithms for faster access or traversal, shortest path, all those things. So graph database is good when we talk about complex or deep relationships. Talking about sessions, or you can say key value based data, for that we can use key value database like Redis because it is very quick. So like cache also we use Redis, correct. And when we talk about analytics, for analytics we use OLAP database, which is for analytics, right, because it can perform aggregations and other things which are required for analytics, logging, metrics, dashboards in much better way. All right, so this was about database. We discussed in detail about a lot of things. We discussed about SQL, NoSQL, types of NoSQL database, then search database, time series based database, OLAP versus OLTP, which database to use for which feature, correct, so all those things we discussed. So if you have any questions, put those in comment section, I'll try to help you out. And I know because it was a really big video, you might not be able to pick all of the concepts in one go, and that's totally fine. What you can do is like revisit this video and go to specific part if you want to understand that. And yeah, once you keep on repeating the things, you'll get more idea. Okay, if you want me to cover any other topic in my next video, put that in comment section. I'll try to create a video on that part. If you found this video helpful, press the like button, subscribe to the channel and share it with your friends and family. All right then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.